This is a video from section 1.3 in a linear algebra class. Let's take a look at this first example. In each part, find a 6 by 6 matrix Aij that satisfies the given condition. Make your answers as general as possible by using letters rather than specific numbers. Let's take a look at part A. Suppose A sub ij equals 0 if I doesn't equal j. So if you're along the main diagonal of this matrix, we don't know the value of the entry. It could be 0, it doesn't have to be 0. But if you're off the main diagonal, we are guaranteed that that entry is 0. So let me give you an example of what I mean. Now, if we look at the first row, first column, I'm going to call that A11. Notice how the row equals the column. And so we don't know if that entry is 0 or not. And because we don't know, we're going to call it A11. But if we go the rest of the way, those are all zeros. So we got 1, 2, 3, 4, 5 zeros. Okay? And then I'm going to go 0 because for that entry, the row doesn't equal the column. That 0 is in row 2, column 1. But if I go over here, I'm going to call that A22. 0, 0, 0, 0. And then I'm going to go 0, 0, A33, 0, 0, 0. This is what they mean by make it general. Then I go 0, 0, 0, A44, 0, 0. Then I go 0, 0, 0, 0, A55, 0. And then I'm going to extend these brackets out a little tiny bit. And then I'm going to go 0, 0, 0, 0, 0, A66. So when you're along the main diagonal, you have to use letters, right? Because when the row and the column are the same, we don't know the value of the entry. But when you're off that main diagonal, all those entries have to be 0. And that's how you do part A. Let's take a look at part B. This one's interesting. Now, in this one, I'm going to say Aij equals 0 if I is bigger than j. So in other words, we're saying the row is bigger than the column, so to speak. Okay? Now, let's check this out. And we'll call it A again, new matrix, right? So over here, I'm going to call this A11, right? So this is the entry in the first row, first column. Right there, can you tell that I and j are equal, right? And then I'm going to go A12. The row is not bigger than the column. A13, A14, A15, A16. Okay? Now, if we go to the second row, now look, I'm going to write here A21 just for a second, right? Can we agree that this entry is in row 2, column 1? Notice how 2 is bigger than 1. And if the row is bigger than the column, that entry has to be 0. And so it is perfectly appropriate to say 0 instead of A21. Okay? Then I'm going to go A22, A23, A24, A25, A26. Now, if we go to the second in this case, the third row, right? If I write an A31, A32, notice how this is the third row, first column for the first entry, and then third row, second column for that second entry. The row is bigger than the column. And so these guys have to be zeros. But if I go out the rest of the way, it's A33, A34, A35, A36. And then if you see the pattern here, I'm going to go 0, 0, 0. And then I'm going to go A44, A45, A46. Okay? And then it's 0, 0, 0, 0. A55, A56. And then lastly, 0, 0, 0, 0, 0, A66. And that's how we do part B. Now, let's take a look at this one. Suppose we do part C. Suppose IAJ equals 0 if I is less than J. In this case, the column is less than, the row is less than the column. Okay, so it's just a slight change from part B. So A is, now here we're going to go A11. Now I'm going to write A12 for the moment, right? Notice how the row is less than the column. And if the row is less than the column, we're guaranteed A12 has to be 0. And then it's 0 the whole way out. 1, 2, 3, 4, 5. Now, I'm going to write A21. Now, why can I write A21? Because the row is greater than the column. So we don't know if it's 0. Then I'm going to write A22, 0, 0, 0, 0. And if you guys can see the pattern, I'm going to do A31, A32, right? A33. The minute I hit A34, the row is less than the column. So it's 0, 0, 0. Then it's A41, right? A42, A43, A44, 0, 0. Okay, we can extend this a little bit further. Then I'm going to go A51, A52, A53, A54, A55, 0. Okay, and then lastly, we're going to do A61, A62, A63, A64, A65, A66. And if you notice, the zeros all appear on the upper side of that main diagonal. Over here, the zeros appeared on the lower side of the main diagonal. So it literally, they mirror each other. So it's just slightly different. Now, let's take a look at D. D is really interesting. In D, it says AIJ equals 0 if the absolute value of a minus or I minus j is greater than 1. Now, what does that mean? What that means is the difference between I and j, right? If we take its absolute value, it's strictly bigger than 1. So let's take a look at that. I have to put A11 here, A12, because now look, 1 minus 2 is negative 1. The absolute value of negative 1 is 1, and that's not bigger than 1. But notice how the minute I hit A13, right, isn't the absolute value of 1 minus 3 equal to 2? And 2 is bigger than 1. And so that ends up being 0. In fact, the rest of the entries will be 0. Okay. Now I'm going to go A21, A22, A23, right? I hope that makes sense. But the minute I get to A24, right, isn't 4 minus 2, 2? And 2 is bigger than 1. And so I claim that's going to be 0. And the rest of these are 0. Then when I get to A31, this is where it gets more interesting. Now, the absolute value of 3 minus 1 is 2. 2 is bigger than 1. And so that is absolutely 0. But when I get to A32, I have to put that down in full. A33, A34. And then it's 0, 0. Okay. Then I'm going to do A41, right? I'm just going to put that temporarily. Now take a look at that. Isn't 4 minus 1, 3? And 3 is bigger than 1. And so I can replace A41 with 0. And same thing with A42, that's going to be 0. A43, I have to put A44, A45. But when I get to A46, it's 0. So let's keep going. I want to finish this problem. Now, A51, right? That's 0. A52, 0. A53, 0. Then I'm going to put A54, A55, A56. Okay? A61, 0. A62, 0. A63, 0. A64, 0. A65, and then finally A66. And so that's the interesting matrix, or at least I think is interesting matrix you get. Okay, so this concludes this video for section, this is 1.3, and we looked at a problem from homework. And then in the next video, what I want to do is I want to show, given that A and B are n by n matrices, I want to show that the trace of A plus B is the trace of A plus the trace of B. Because I want to show you how to work with summation notation. Okay, again, this is section 1.3, and we worked on a problem from homework. All right, thank you.